So we have a skier going along. We know the velocity they're moving at. We don't know their mass. We're going to ski along, and then we're going to go up a slope. So, woo-hoo. All right, the fun part of skiing is going down the slope, but we're going to go up a slope. And the question is, after we get up here, all right, after we get up here, what is the velocity? So what do we know? Physics is all about putting together a puzzle. So let's talk about what we know. We know the initial velocity. We know, because that's 7.16 meters per second. We know the height that the skier goes to. That's 1.02 meters. We know the acceleration of gravity, 9.8 meters per second squared. And so we know all of these pieces. What do we know? What else do we know? We know conservation of energy is going to apply because there's no friction. And so we know our initial kinetic energy, no frictional forces, initial potential energy is 0. It's going to be our final kinetic energy plus our final potential energy. So we can start thinking about putting these pieces together. It's a puzzle. So you start with the corners. And the corners are the things you know. And then you start working edges. And the edges are the equations. All right? So you've got your corners, the things you know. You have your edges, the equation you can use. So you can try different equations. But in this case, we're going to go to this one. So 1/2 mass times velocity initial squared equals 1/2 of the mass of the skier times their final velocity squared plus mgh. And here's the thing that we find out when we do this. The mass all divides out. We're left with initial velocity squared, final velocity squared, and gh. And what we're after is that piece right there. So we started with the corners, we went along an edge, and we got to everything fits together, and we can figure out the one thing we don't know. Velocity final squared, multiply through by 2, subtract, velocity final squared is something like velocity initial squared minus 2gh, and you can do the rest without any problem. And there you go. That's how you solve problem 4.